Ladies and gentlemen, good morning, good afternoon, or good evening, depending on where you are. Welcome to Transport Events Market Leading Webinar, broadcasting live simultaneously on Zoom, YouTube, LinkedIn, and Facebook. This week's theme is entitled Advanced Cable Solutions for Electrification and Sustainability, generously sponsored by Prysmian Group. My name is Ajay Haridas, Conference Manager at Transport Events, and we would like to first of all take this opportunity to thank Prysmian Group for sponsoring this week's webinar and for making this webinar possible. I now have the pleasure of introducing you to our four distinguished panelists. Ms. Jana Blechschmidt, Head of Technical Sales, Crane Export, Prysmian Group based in Germany. Mr. Andrea Benedetti, Product Manager, Cranes and Mining, Prysmian Group based in Germany. Mr. George Franz, Head of Shore Power Collection Business Unit, Stemmann-Technik based in Germany. Mr. Martin Teiling, Industry Manager, Shore Power, igus, based in Germany. And our valued moderator for the webinar today is Mr. Anthony Versluis, Senior Advisor, Maritime Sector, Roland Berger, based in Malaysia. The theme today will discuss electrification and sustainability solutions for ports and terminals. Please type your questions for the panelists now or during the presentations by clicking on the Q&A button at the bottom of your screen. This can only be done on Zoom, so if you wish to ask any questions to the panelists, please do so using Zoom. Our esteemed moderator, Anthony Versluis, has more than 30 years of professional experience, most of which he spent in consulting for the ports and maritime sectors around the world. He has managed hundreds of port projects covering all aspects of port development, including strategy, planning, construction, operations, and performance. Anthony is currently Global Senior Advisor for the Maritime Sector for Roland Berger, and advisor to several global port operators. He holds degrees in Mechanical and Industrial Engineering and in Industrial Management from Dutch universities. Anthony, with that, over to you. Anthony, you need to unmute. Unmute.
Sorry, Ajay. Well, thank you very much, Ajay, for your kind introduction. Can you hear me now properly? Correct? Yeah. Can you hear me now?
Yes.
It's always a pleasure to collaborate with you on this, on these webinars and seminars organized by Transport Events. Today's topic is maybe somewhat specialized, but it is very relevant because the topic of sustainability, green ports, green shipping gets more and more attention all the time, and there are many ports around the world, in Europe and in Asia and everywhere else, that are struggling with this question. So we're very pleased to have this opportunity to talk about electrification and electrical cables in the context of the green port requirements and trends that we are seeing. I would like to start with introduction of Jana Blechschmidt. She started in 1996, a long time ago, at the Siemens cables factory, which was in Germany, which was eventually taken over and absorbed by the Prysmian Group. And the key focus of her work over all these years has always been application engineering, as well as technical sales in the cranes and ports industries. So now, with almost 25 years of experience in that business field, she is the head of technical sales for crane cables for the Prysmian Group. Jana, may I kindly ask you to proceed with your presentation?
Thank you very much, Anthony. I'm going to share my screen. First of all, a very warm welcome to everybody joining us today for this webinar. It's a great pleasure to have you on board and discuss about the solutions for sustainable port operations, which is more and more a #1 topic in all the discussions on all levels. But first, I would like to start with a brief introduction if the screen is moving.
Yeah, it's okay, Jana.
Can't get on the second page. Just a moment. Okay, sorry. Here we go. First of all, brief introduction of Prysmian Group. We are the world's biggest cable manufacturer and solution provider with more than 100 plants in 50 countries all over the world, around about 29,000 employees worldwide, and a very strong power with 25 R&D centers all around the world. What we offer is we provide our customers and communities worldwide with cable solutions that are based on the state-of-the-art technologies. It's based on an in-depth understanding of the demands that are coming from the market. In our centers and plants in Germany, we specialize in different segments within the industry, and Germany is the home of Prysmian's Competence Center for Crane Cables. It is our target to satisfy our customer with the best and most sustainable solution for his applications. This is fundamental for our future growth. So hence, our very core of our business is to provide our customers with technologically innovative, safe, and sustainable solutions. Sustainability, it's one of the key words in our today's program. And electrification is part of that, in particular, when it comes to port operations. Nothing works without power. And therefore, we have developed a whole cable package to help our customers, to help terminal operators to reach the target of zero emissions in the port operations. So it's more than just cranes. Besides the crane cables and the crane operations, there's also a need to generate power. And we have the full cable range for power generation with solar or photovoltaic. We do have the cables for wind energy generation, both the local grid, but also the flexible cables inside the wind turbines. We do a lot of cables for EV charging for all the automated and electrified vehicles in the port. We have a green portfolio for the local infrastructure inside the port. And last but not least, very important nowadays is our shore connection cable to feed vessels, to feed cruise liners with the energy from the local grid. Having said that, I would like to draw your attention today on our medium voltage reeling cables, because not all port operations are requiring the same cable solution. That is very much depending on the equipment that we are driving. From the outside, power cables look pretty commodity and very similar, but from the outside looking in, you find a different level of engineering inside the cable with the focus on best value for money. Our Portalone cable family has a new member, considering those applications of elder cranes, of cranes that are not driving too fast, of cranes that, like mobile harbor cranes, are not running long distances in the port. Short for applications with moderate mechanical stress. Our Portalone SMK 200 is made and available for these applications. Portalone SMK is our classic and most popular reeling cable for operations with high and highest mechanical stresses. And for the increasing number of high-speed applications in the board, such as ASCs, ARMGs, we have developed our Portalone SMK HS, with the HS standing for high speed, which is the big sister of our classic Portalone SMK. And we complete our Portalone family with our premium solution, Portalone IQ, which is a cable monitoring system that observes itself and its ambient conditions during the operation to prevent the cable from failing. The whole Portalone cable family is engineered and 100% made in Germany, from the copper drawing and laying of compounding and vulcanization. Now let's take a closer view on each of the products, starting with the new release Portalone SMK 200. The design of this cable is optimized for reeling operations with a speed of up to 200 meters per minute, and it can handle a tensile force of 20 kilonewton per square millimeter copper conductor. Waving features that are not needed in those moderate applications, the cable is focused to do the job, power supply to the brain. The cable is high flexible and easy to work with. It's not compromising on the reliability and the performance. It works reliable even under very harsh conditions. And as always, we use our Prysmian-made high-grade compounds for small OD and less weight. The cable is the perfect solution for low and moderate speeding reeling operations. And here comes our classic and well-known Portalone SMK. This cable has an unbeatable high number of references in the field all around the globe. It stands for reliability, long lifetime, and customer satisfaction. The design is optimized for reeling operations up to 240 meters per minute. And the cable is super flexible, built with innovative high-grade compounding, developed and made in our own compounding department. It is using state-of-the-art compounds for insulation sheath system. And for that reason, we are able to optimize the cable in diameter and weight. And also to, if you compare that to the previous generation of cables, we are saving here around about 30% of cable OD and weight. The cable can handle and resist very high mechanical stresses, and we tailor the configuration according to your specific requirements and deliver it with or without integrated fibers, with twisted shielded pairs, with pilots or any sort of control course. The big sister to Portalone SMK is our high-speed cable Portalone SMK HS. With an integrated support element in the cable sender, we are able to increase the permissible tension to this cable by a minimum 1000 Newton on top of what the copper can do naturally. The other important feature is the very compact core assembly, core design. We are saving diameter by doing this compact inner cable design and give this saved room to the sheath system actually, in order to help the cable to handle better all the stresses that are coming from the outside into the cable sender. Both features together result in a suitability of cable for very high speed operations. In fact, there is no speed limit for this cable. And of course, we also manufacture this cable with customized configurations such as integrated fibers, twisted shielded pairs, or any other sort of bus applications, pilots, and control cores. But nevertheless, all the three cables that I just showed to you are dealing with symptoms that are coming from the setup of the equipment. The cable that is made to actually control the symptoms, actually to control how it is treated, is our monitoring cable Portalone IQ. Faster, greater, broader, plus the fact that operations of cables are almost permanently at the specification limits, is causing a tremendous extra stress to the cable. The tolerance of the cable to handle stress peaks that are coming, for example, from installation failures, from incorrect machine setup, or insufficient maintenance even, is shrinking. And of course, that results in sort of cable's lifetime limitation or shortening. To better control that, and we can't measure what we can't control, we have developed our monitoring system called Portalone IQ. Portalone IQ is a revolution because it's more than just a cable. It is composed by 3 main elements. First of all, enhanced Portalone cable, because we are embedding, as you can see on the right side of that slide, a special sensor fiber that is dedicated to measure mechanical stress load. On top of that, we have a measurement device which can be installed either in the e-house on board of the crane or in the substation where your other equipments are located. The device is then connected to the fiber inside the cable through the local fiber infrastructure. These elements together will allow to build up a stress diagnostic system, which is the 3rd main element. We are able to look in real time what are the events happening to the cable during the complete operating hours. We detect mechanical stresses such as strain, bending, and torsion, and the system is able to detect both sudden events, irregularities, but also slowly upcoming stresses, for example, twist. We already see first signs of twist months before the visibility from the outside of the cable. That can result in an immediate action and adjustments to stop the twist before the cover is deformed and the twist is becoming visible. The global warming is, it's kind of funny, opening the Northern Sea route, which means there are a lot of requirements coming from the field today for so-called icy cold operations, up to -50 degrees, fully flexible. And we have adjusted all our cables that I showed you before to an Arctic cable design. It's still a Portalone SMK, but we have developed special compounds that can deal and resist with this very cold and strange ambient. These cables are excellent, flexible, also at temperatures of -50 degrees, resistant to oil, also on UV, which is also a very present factor in the north, to moisture and water. And we have this cable available for all crane applications, not only the main power supply, but also the spreader reeling cables, the festoon cables, the chain cables, any sort of moving part on the crane is also available for -50 degrees. And to complete the Portalone family, that brings me back to the very first slide, the green port slide. Environmental friendly feeding of docking vessels is a topic which we are having a focus on with the next presentations that we will see. We have developed a Portalone cable, which we call a shore connection cable, that is used in this application. To be honest, this application is not really looking very demanding, but this is very underestimated because during the connection, the cable has to deal with relative movement, with tide, going up and down. There is a permanent moving and there's a lot of tensile force on the cable. So it has to be designed in a smart way, even if it's not permanently reeled, but only pulled out to plug in. Plug in, that's one of the central question marks on these cables, because you cannot expect a vessel owner to have 100 different systems installed just to plug in or to be able to plug in anywhere in the world. So it has to be kind of unified to make the ship owner able to plug in any port around the world. So we as Prysmian have such plug and play solutions in-house. We manufacture the cable and terminate already the cable in the factory, so that you as a customer can have and expect a plug-and-play solution from us. And that brings me to the end of my presentation. Andrea will give you a closer view on our shore connection cables before we continue with the other presentations. Thank you.
Thank you very much, Jana. A very clear presentation. Before we go to Andrea, two questions perhaps. The first one is, they both refer to the IQ software, IQ fiber addition to the cables. My first question is, this sensor fiber cable sensor, so it takes measurements all through the cable, I suppose, right? That facility or that addition, can you add that to all your different cable designs, or is that only for one cable design? That's my first question.
At the moment, we have this technology on the main power supply cables, because these are like the umbilical cords to power up the crane is the most relevant application in the field. So right now, we are focused on this medium voltage relink cables for the power supply of the crane.
But you could over time add it to other types of cables as well, presumably. It's a matter of product development, presumably, certainly, right? Yes. Yeah. Okay, the second question is, you elaborated on that already a little bit, what you can measure the stresses, the twist, you can sort of predict when stresses are going to rise, etc. So that information comes on a computer screen somewhere. What exactly is the total package of information, in particular, in terms of what then the software would advise you to do with that information, like stop the crane or replace the crane, or what exactly are you trying to achieve with that information? Okay, let me summarize
what our IQ software is able to measure, to the measurement metrics. The first metric to mention is the average of deformation of the cable on the whole cable length, but also at each position along the cable.
Right.
This is an indicator of progressive stresses that is building up on the conductor inside the cable.
Right.
Copper is something that never forgets.
Yeah.
Once it is deformed, it is not apologizing and going back.
Yeah, correct.
The second metric is the tensile force applied on the cable, which is to be compared versus a threshold defined by the cable manufacturer, which is the maximum applicable tension.
Right.
Further, the correlation between strain peaks and acceleration. We are putting two information together, which is the acceleration of the cranes through an accelerator and the strain peaks that the IQ system is detecting. This allows conclusion if the control system is not perfectly set up.
Right.
Another metric is the time that the cable spends in an elongated state, which, for example, indicates a poor coiling performance between the cable and the reeling system. Also, the measurement of torsion is an important metric, which again is to be compared versus a threshold defined by us, by the cable manufacturer, which is the maximum permissible twist angle per meter.
Right.
What we finally come out with is an estimate of fatigue.
Right.
Fatigue is depending on the number of cycles of the cable, and it makes a difference if an operation is 24/7 or only 5 shifts a week. What we do with our IQ system is an estimation of fatigue through the so-called live point counters.
Right.
And last but not least, the software is programmed to automatically calculate the quantities of all the mentioned metrics and puts it in a sort of a bookmark in a virtual calendar, explaining what happened, when it happened, and where along the cable it happened. And this kind of information can, for example, be integrated in the crane management system.
Right, right. Who in your experience is when it comes to working side, who in your experience is most likely going to react to this? Is this the crane operator, or are these typically the maintenance management people?
partner both. I mean, the focus here is clearly on preventive maintenance.
Right.
So the first actor is certainly the crane operator.
Right.
It's also possible to make an active system out of this data that you measure and the metrics that I just mentioned,
right.
to convert that in a direct action.
Yeah, yeah. With alerts and everything.
Exactly.
Yeah. Right. Okay, got it, got it. I would like to remind the audience for a moment that everybody should be submitting questions, because some of the questions can be answered during the presentations, and some of the questions we will address more in detail during the panel discussion towards the end. So everybody, please, if you have questions, please put them up, and we will deal with it in the course of this webinar. Okay, thank you very much, Jana. Then we're moving on to Andrea. Andrea is also with the Prismin Group. He's the product manager for special cables, focused on sustainable electrification solutions for the crane industries as well as the mining industries. What is interesting about Andrea is that he is in his mid-30s and yet has never owned a car. So this is very interesting. So that is like looking ahead into the future. So Andrea, I'm very pleased to introduce you. So please proceed with your presentation.
Thank you for the introduction, Antoine. And yeah, I think that's it's important nowadays to have a sort of red thread between our beliefs and our work that we do, so that we actually work on what we think it's good for the environment and vice versa. So I will share my screen, and then I will start straight away with my presentation. I'm not finding the button to start the screen sharing.
The button is below your screen, the share screen button.
Yeah, sorry. We discussed yesterday during the trial. We're all used to we're using too many systems nowadays. Okay.
Perfect. There you go.
Here we go. Okay, so you have seen from the presentation from Jana a nice overview of the entire package of medium voltage reading cables that we supply under the brand name of Portalone cable family. What I will deep dive into here is into the Portalone SC. So this is the cable that is dedicated to flexible connection of shore connection systems. And this will open up the chapter also of the shore connection system that we will see in the next presentations from the next panelists that kindly joined our discussion today. But first of all, to start with my presentation, I want to take a step back and just define what terms are we discussing today. So what is shore connection? Basically, for the ones that do not know this kind of technology yet, it comes under different names. We hear about high voltage shore connection. We sometimes hear about alternative maritime power. Then there are people calling it also cold ironing or shore to ship power. These are all different names, all different terms, just indicating the same technology, serving the same purpose, which is to connect the ship to the main grid while the ship is at berthing, and to provide energy, the energy demand to the ship from the grid, instead of using the diesel engines. So the ship can shut down the diesel engines and get the needed power from the main grid. What are the advantages with this kind of technology? Of course, we can or the port operator can reduce the carbon emissions. It does reduce the fuel consumption, and also, last but not least, it also reduces the noise connected with these big vessels that are polluting the air, the water, and also the overall environment of our ports nowadays. So we do have a lot of different terms for the same technology, but we do have also a lot of different technologies when it comes to shore connection systems. Basically, I've collected here some of some pictures of actual connections, shore connection systems that employ our Portalone shore connection cables. And this is just to give you a glance of the many different cable management systems that there are on the markets. We will see more of these in the upcoming presentations. Yeah, we see here how various this kind of market is. So we have on the top left a mobile wagon with a retractable arm for cruise liners. On the bottom right, we have a typical reel system used for container vessels. In the center, we have a retractable connection for LNG vessels. And then on the right hand side, we have a cable dispenser for ferries, and also below a semi-fixed cable connection installed basically on the quay as an extension cord. So many different systems are available on the market, but what do all these systems have in common is that they all need a cable, a shore connection cable. And I'm coming back here to what Jana says. It might seem that the cable is not a demanding environment for the cable, but I can tell you this is not the case, because we cannot limit our we do not have only one solution or one technology. We have such a wide spectrum that we need to think about all the ways that the cable will be used and will be put under stress by different kind of environmental conditions. And the good thing is that for all these systems, we have just one cable type that can be used for all these kind of technologies. And I will show you in the next 2 slides what we are talking about. I said one cable, different technologies, one cable, which is the Portalone SC. SC stands for shore connection. We do, however, have different voltage ranges. So the first cable that I'm showing you here is a medium voltage cable. Medium voltage cables for cruise liners or for container vessels are usually either, or let's say the electrical systems are usually on 6.6 kV or operated on 11 kV. So to cover this range, we have cables that we have medium voltage cables that cover the range from 10 kV to 20 kV. And but the construction of these cables is pretty much the same. What changes is the dimensions, of course. And they all have, first of all, 3 power cores in the center that are made of flexible bare copper conductor class 5. Class 5 is an indicator that the copper conductor is highly flexible, so it's suitable for bending, is suitable for continuous reeling application, and so on and so forth. And what we have then around the copper conductor is a triple layer with an inner semiconductive, an insulation layer, and then an outer semiconductive. This is the classic design of a typical medium voltage cable. Then in one intersize, we have the ground core, so which is serving as a protective earth, also made of flexible bare copper conductor class 5 with a semiconductive layer. And then in the other interstice, this is quite interesting. Here we have a composite element made of optical fibers and control cores. So we have in only one bundle combined optical glass fibers and standard copper control cores. And this is used then for transmit both signals, but also data at a high rate. Then around the core stranding, we have a first sheath of a rubber material based on EPR rubber. And here it is important to have a water barrier. Because we know that moisture or even water is present in ports, of course. So what we need to achieve here is, or to avoid, is that any water and any moisture enters into the cable. Otherwise, this can be dangerous from the electrical point of view. So the combination of the choice of combination between the inner and the outer sheath, this makes the real difference if the cable is water resistant or not. In this case, we have a combination of inner sheath based on EPR rubber and an outer sheath based on CPE rubber. And this outer layer provides both the water protection, but also it is abrasion resistant and resistant to, of course, to UV, but also to the mechanical stress that is related, correlated with the typical reading operation, for example. In this case, so we need a tough outer sheath that will protect the cable from getting damaged through dragging and reeling the cable on the reeling system. So this is the typical design of a medium voltage cable. We do have then this design also in a low voltage configuration, and the low voltage system looks slightly different. We also have here power cores, also made of flexible copper conductor class 5 with EPR insulation. In this case, since we are in the low voltage, we don't need semiconductive layers, so we only have an insulation layer here. In the interstices, we have 2 ground cores, also made of flexible copper conductor class 5. And then in the third interstice here, we have a combined element with 4 control cores or even higher if the request of the customer is different. And in this case, in this configuration, we don't have fiber optics. But again, this is a choice of the customer or a choice of the system where we are delivering our cables to. Then for the inner sheath and the outer sheath, here we have the same materials. The only thing that changes is the color of the outer jacket. Typically, because a red color is connected to danger, so this is typically used for medium voltage cables, while other colors like black or yellow is used for low voltage cables. So in this case, the choice of a black outer jacket, also based on CPE rubber, and as I said before, water and abrasion resistant, whilst the inner sheath is water resistant, so that we have a perfect water submersibility of this cable. So the cable can be permanently laid underwater if the requirements are such. And then we move on to the next slide to summarize the main features of these cables. The first feature that I want to mention, this is very important. All these cables that I just showed you are all compliant to the international standards, and the international standard for short connection system is the IEEE 8005. It is definitely important that we are compliant to this standard, not only from the design point of view, but also from the testing point of view, to guarantee that our cable do have and maintain a certain quality level throughout the production process and throughout the years as well. To do so, we also had the support of Bureau Veritas in this case, who also tested independently the cable and certified these cables as being according to the IEEE 8005. The next thing, which is quite important, is that the cable has to be suitable for all vessel types, regardless if we're talking about container ships or cruise vessels or a ro-ro or ro-pax vessel, and so on and so forth. Why is that? As I showed you before, we have different technologies, but the cable is the same. So for this reason, the cable needs need to be somehow need to be used or must be used for different ships coming into the port. And then the next important point is the fact that the cable is designed for reading application, for reading operation, but also is therefore also suitable for semi-fixed systems. The reading application is definitely the most demanding application that we have in this field, because the cables are then being reeled on and reeled off quite often, maybe a couple of times a day, also subject to tensile strength or to tensile force. So this is definitely the application that that we need to meet in order to make sure that the cable is suitable for this kind of environment. And then everything else will be basically a class lower in terms of mechanical stress onto the cable. Definitely one important point to mention is that the cable needs to be highly flexible and mechanically robust. And this is to guarantee high reliability over the course of the lifetime of the systems. And then, of course, since we're talking about an outdoor environment, the cable needs to be resistant to UV, ozone, and moisture. And also an additional point where we are the only one on the market offering this kind of feature is the permanent immersion in water. So the cable can be for the entire lifetime be immersed in water without any restriction. And as mentioned already before in the previous presentation from Jana, this cable can be also delivered with pre-mounted plugs or terminations on request according to the customer specification. So summarizing our catchphrase here for this kind of application is just shut off and just float. So with Prysmian shore connection cables, you can just shut off the engines and float, and the cable will provide energy and data transmission to the ship while at berthing. So Portalone shore connection, it is the perfect choice for medium voltage and also low voltage connection systems for this kind of application. The cable will provide energy, but also data communication to the vessel. So at the same time, the diesel engines can be turned off, saving fuel, pollution, reducing carbon emissions and noise. And everything that we do is compliant to the industry standards. So in this case, the IEEE 8005, Bureau Veritas certified, and suitable for permanent immersion in water. So this is everything I had to tell you today. These are our contact data if you want to reach to us. And then now I leave the word back to Antoine.
Thank you very much, Andrea. Very clear. I have two questions for you. The first question is, there are small ships and the big ships, and the bigger ships presumably would have much higher power and voltage or power requirements than the smaller ships. So they might require multiple cables or multiple supplies, or at least a lot more kilowatt hours or kilowatts than the smaller ones. How do you deal with that? The second question is on the plug side. With regards to the ship, since it's Bureau Veritas verified, I'm sure on the plugs for the ships is not really a challenge. But I would imagine that the plugs or the terminations and the connections on the land side with the substation or with existing cable systems, the variety there would be, I am assuming, much wider and much higher. How do you deal with that question? How do you deal with that question? So those two questions, please.
Thank you. Thank you. thank you for the questions. For the first one, both questions are in regards to flexibility of the system, of course.
Right.
And to your first question, yes, you're right. Different ship classes require different amount of power, and in that case, it is quite typical that more than one cable will be laid aside to each other. So we will see also later on in the presentation that we will have up next that a typical configuration is with either 2, 3, or even 4 cables laid in parallel, exactly to provide this high amount of energy to the ship. Of course, what we can do from our side, from the cable producer point of view, is to play with the different cross sections that we have. So of course, if the power demand is lower because the vessel classes are a number smaller in size, then we will provide cables with smaller cross sections, so with less copper, so with less amount of current that can be transmitted through the cable. If the amount of energy is higher, then we will move up. So the standard size is 185 square millimeters, but we can go up to even 240 or even 300 square millimeters.
Right, and the design of the cable is all the same. They just
well, yeah. The design, the concept is the same. Of course, what will change will be the dimensions of the cable, because
right.
We will have bigger copper conductors inside.
Right.
But what is important, what matters at the end, is that we keep the same flexibility of the cable itself. So this is definitely one thing that we can achieve even with bigger cross sections. And to your second question, yes, there are different specifications for plugs, mainly in regards to the design of the plugs. Of course, in the industry standard, the IEEE 8005, there are also some specification in regards to the plug, how it should look like. Not all the plug manufacturers are there consistent, let's say, but we do have experience with the 4 biggest plug manufacturer integrating our cable or making a system between our cable and their plug system. So we can safely assume that with this we cover basically the whole range that is available on the market right now.
Right, and if you get an order, are you typically asked to supply the plugs, deliver the cables with the plugs, both for the sea side and the land side? Is that the normal situation?
Normally only on the ship side.
Right.
On the land side is normal connection box, but yes, this is quite typical.
Right. Okay, thank you very much for your presentation. Then let us move on to the next one. Mr. George Franz Matskou, Head of Shore Power, Head of Marketing, Power Collection Business Unit of Stemmann-Technik, GmbH. That's not a German pronunciation, my apologies. I don't know exactly how to pronounce this in German. George is an Austrian executive sales and marketing expert in the role of Head of Shore Power for Stemmann-Technik, which he joined in 2010. Stemmann is a leading manufacturer of shore power solutions and energy and data transfer of components and systems in industrial and transport technology, so a little bit outside the port sector as well, presumably. George, I'm very happy to introduce you, and please proceed with your presentation.
Thank you, Anthony. So I'm sharing my screen. First of all, thank you very much, Prisming Group, for having me as part of your panel here today. It's a great pleasure. Also, thank you very much to Transport Event for organizing the webinar. That was great work. Thank you for that. Talking today about advanced cable solutions. Wait a second now. For electrification and sustainability. I will talk, as mentioned before today, about cable management for shore power. And thank you, Anthony, for giving the audience a rough idea about who we are and who I am. I'm working for Stemmann-Technik, German company. We've been bought a couple of years ago, 2014, from Wabtec, that's Westinghouse Air Brake Technology. This is a railway company. So Stemmann is a comparable small company with a couple of hundred people working in Germany. And our mother company is in some, well, let's say close to 30,000 people, meanwhile, a bit bigger and a lot in railway. So we are just a small part of the complete group. Talking about shore power and cable management today, bit of repeating what Andrea already told you. So what's the challenge here in shore power in general? There's some names and nouns being aware in the market, like Kyoto Protocol and Paris Climate Conference and IPCC. So what is this about? So practically speaking, a couple of years ago at the Paris Climate Conference, roughly 200 countries decided we are willing to reduce, or we are trying to reduce the rise of temperature with a maximum of 2 degrees Celsius above the pre-industrial level. And this is so important because the IPCC realized or found out that it's extremely likely that it was the humans who influenced, that as a dominant cause, the global warming in the last 60 years. So if we don't care on our planet, then that's it, practically speaking. A couple of things happened, and we are looking forward to governments even trying to put some more pressure and not just nice words on the market. So they even say we are looking forward to make you pay if you keep on doing pollutions. So if we want to go green, if we want to reduce carbon dioxide, there is in the ports and maritime business a couple of things we can do. Don't worry, I will not talk about everything here. I'll reduce it on shore power, as you see on the left side, as well the ship side installations as the land side installations. But of course, there is much more things which can be done at the moment. To give you a better understanding more on a general point of view, so what Stemmann is doing, we are doing the cable management, which means that to cover the distance between the shore and the ship side, or the ship and the shore side. However, so it's in between the ship and the shore. We are not doing the substations, we are not carrying on the grid, we are not electrifying the complete ship, we're just doing the handover, and it can be very individually. The reasons to go green, I just try to sum it up. There is, to me, that's 3 core reasons. First is I should better do it, because let's say my stakeholders, my local and national politics, my NGOs, they say you need to do it. We are your voters, we are your neighbors, we are your friends, we are your employees. We want you to go green, which can put some pressure on the ports and on the ships, of course, too. Some of these people say, well, there is quite some funding at the moment, so maybe I should just grab the money and do it before there is no funding anymore in the future. However, second point could be, I want to do it. I mean, usually money counts, and if there is a chance to get things cheaper, usually the people just run. So there is some situations in a business case where it might be just cheaper to go for shore power compared to stay on diesel, especially when the price per kilowatt hour of green energy is cheaper than the price from the diesel to care on it. At least I can tell you for Germany, this doesn't work at all. In Germany, the price for diesel is much cheaper than for green energy. So there will be some more reasons to do that. One of it is corporate targets. if you have a look into sustainability reports from the big companies, I just read the other day that MSC is showing it. They APM is coming up with it. They say we want to go green. We want to go on a zero emission strategy until 2040, 2030. Others even earlier. So this could be one of the targets, the reasons to do so. And last but not least, there is some practical advantages, sometimes at least. Sometimes the people say, well, if you want to work 24 hours night and day, you need to reduce emissions. And as Andrea already mentioned, it doesn't need to be just the carbon dioxide. It could also be vibrations, let's say, or it could be noise. So the people in the city say, I do not want to sit next to a harbor where it is always that much noise. I want to sleep in the night. And last but not least, the I must reason. So it's defined by law, at least in some countries, as we know it from California in America, or as we see it in Norway coming up in 2026, or as we see it and hoping for it in the European Union. We are looking forward to a must in shore power. And last but not least, for this one, there is regulations and norms which say how to handle it and how to deal it. Also recommending what Andrea just told, it's the IEC standard 8005/1 for high voltage and /3 for low voltage, which practically says how to handle it. You can find all the interfaces, you can find the plugs, you can find the kind of cable in general, of course, not the company. And you see how the single line diagram needs to be done. So actually, everything seems to be quite easy, because when everything is in a rule, then there is no problem, except for one. There is the problem that every port is different. You cannot just take one solution and bring it from Hamburg to Valencia or to Piraeus or to Athens or to, I don't know, Honolulu, because every port looks completely different. So you need to make sure that your solution you're asking for fits to the infrastructure of the harbor. And this, of course, is the main problem. So that's where we see the biggest challenge in the cable management, or in the cable handling and the cable handover, how to hand it over so that it fits to the local requirements. Giving you a quick overview, I just shown here some applications running worldwide, whether it's cable cranes, as you see it in the upper left level, or whether it's running in a container vessel, as you see it here on the right upper part. It could be done on a small cable reel placed on the port for offshore support vessels, or for some cargo vessels, or for some bulk carriers, or maybe for the cruise, as we know it from Hamburg and from Kiel and from Rostock and from others. We just handed over in an FAT, which happened last week, the latest shore power solution for the port of Southampton, which will be shipped on Monday next week. So there is another solution coming up from Stemmann-Technik, which will run in the world, and we are really proud of this one. And coming to the last picture on the right bottom here, this is for a RoPax vessel in Poland. So it doesn't need to be a movable solution only for cruise. You can also use this for RoPax or maybe for car carriers. To sum up, I mean, the world is really facing massive problems ecologically and economically. And it's time to act right now. If we really want to do something, if we really want to reduce the increase of temperature, and the aim actually is 1.5 degrees, it's not 2, then we need to do something. The governments, I mean, even the governments are acting meanwhile with restrictions on money, with new laws. We are aware that although every man are created equal, practically every port is created different. So we need to put some clear point on this one. We need to do customized solutions. We cannot just copy paste from one berth to another. And that's my last words. I believe it's not easy being green, but it's really worth it. Thank you.
Thank you very much, George. That was very interesting. So you're working on a whole range of different technical solutions for different situations, essentially, if I understand you correctly, right? I can see, yes, in every port is different. Also, every berth is different within the same port, which makes it more complicated. And I would assume that the most complicated situations are actually the ports that are the oldest and the most varied in the types of berth and infrastructure they have within that port area, right?
Right.
And if I look at container berths, one beautiful thing is, of course, there is a distance between the vendors and the edge of the quay, which is not the case in general mixed cargo berth. In dry bulk berths, that's typically also the situation. In those type of berths, we also have the cranes running on rails, and along the rails there is a channel where the normal cables are running, feeding the cranes, right? But in old mixed cargo berth, there is none of that. There are no cables in the surface. There are no rail systems. There's nothing by way of overhead structure. So you need to just lay out the cables on the surface from running it from some point to the ship. In which case there's no protection for the cables, and the trucks have to drive right over the cables. What is your advice for berth like that, generally speaking?
Okay, thank you for the question, Anthony. I mean, usually what we see is that the cables are brought from the substation underground to a junction box, which is placed on top of the quay, inside the quay, next to the quay. Right. So the main problems we are facing in shore power with what you were asking is just the connection between the junction box and any kind of cable management system. Right. And this can, as you mentioned, this can lay on top of the ground, but sometimes it's just not possible because you need to run over from left to right with your forklifters, with your crane. So there is chance to use kind of cover plates and lay the cable in a trench if necessary.
Correct. So, right. So that is one approach, right? And another approach, and I mentioned that earlier, and it may be something to think about. Is there not a way in general cargo berths, at least, to lift the cables up into the sky, create some kind of towers, as it were, in such a way that they won't interfere with the mobile harbor cranes that you would operate in that area? Is that potentially an approach that you could take?
Well, of course, it's an approach. We could do this sometimes, but we are sometimes just limited in the height because there is other things going back and forth. So there is always a kind of profile you need to be aware of where you can move whatever you bring, your cable, your reels, your solutions.
Yeah.
And that's very often very, very limited, especially when we talk about container berths. There's hardly any space in the front of a ship-to-shore crane to the quay.
Right. Correct.
A meter maybe, or 150.
Correct.
That's challenging.
And if you are invited by a medium-sized multi-purpose port, which does some dry bulk, some containers, some mixed cargo, have a bit of ferries perhaps, what do? You spend a few days on site to assess the whole situation? Is that
of course, I mean, it helps when you go there because you realize what's the situation on site, especially how the infrastructure looks like. But for shore power, it's really important to be aware of what kind of ships are we talking about, because there is for different versions of ships, different norms. So for the container ships, you're looking forward to get the cable from the container ship down to the ground. Whereas for a offshore support vessel, usually you just bring a double or triple spiral cable reel on top of the ground of the shore and hand over the cable, maybe with a crane or maybe with a lifting arm or lifting device to the ship. So it always depends on the kind of vessel, which kind of solution makes most sense next to the question, how does the infrastructure looks like on site?
Right. How long does it take you to make a full assessment of a complete port situation?
Well, usually the people, the ports don't say, please come to me and do everything in once. I mean, of course I would love it, but usually they say we will start first with a cruise, or we start first with the container vessels, or we start first with the RoPax vessels.
Yeah.
Because it's also a question of money. I mean, in the end, you need to get the money, and you need to get the energy from your local energy provider to make sure that if you want to go for shore power later on, that there is some power on your cable.
Yeah. Right. Yeah. There's a lot of complications. Okay, I understand. Thank you very much, George. Let us move on to our last speaker, Martin Thieling. Martin is industry manager for shore power for igus GmbH from Germany. He's been responsible for this business within igus since 2015, and he is focusing on providing flexible cable management solutions to overcome the shore power connection dilemma. I'm very pleased to introduce you, Martin, and I'm happy to give you the floor. Please proceed.
Thank you very much. I hope everyone can hear me and everyone can see my presentation. Great, thanks, Jana. Yes, thank you for having igus on this panel, and thank you very much to all of you to introduce this topic that lets me jump in right into one topic. I want to present you a little bit about shore power system for container vessels, and especially about our igus mobile shore power outlet. Yeah, first of all, it's similar to what George just mentioned. It's the overall context of shore power for a special terminal. So when we're thinking of a container terminal, it's all about profit. It's unloading and loading vessel as fast as possible. Safety first, yes, but then comes automation. Electrification is happening already. All the port equipment is going to be electrified, no matter what. 4.0, big data, it's happening. It's happening, and it's probably overtaking everything else. But going green, zero emission is a big target for the future, for all of the ports, and there's commitment from terminal operators, from shipping lines, and from the port authorities. But when we're thinking about shore power, it somehow has to fit into this environment, and we need to address the overall context. What kind of problems we are facing? The main issue is that the cable management system that is placed on board the vessel of a container ship has a limited deployment length. So in the end, it depends on the site location, on the design of the wharf, and also on the tidal range, because that can be very, very different compared to Hamburg and Kiel, for example, or from Vancouver to Marseille. So you can have a big tidal range, and this can sum up more than 20 meters of movement of the vessel that is needed to compensate this movement. And then you have limited reach for the plugs to plug them in at any place. That leads to the main problem of all the shore power connections, not only for container vessels, but we see this also on cruise vessels. And we have different solutions to address that, but the connection dilemma is really a key issue for all of the ports and designing a shore power system. So you have, every day you have different calling vessels in terms of size, bursting starboard, bursting port side, and then the location of the cable management system on board the vessel can be at various points as well. So in the end, you don't know where to connect the vessel. So not today, but not tomorrow, and foreseeing the future with new vessels calling or new lines calling this berth, it gets even complicated. How does it started, and what can we learn from the past? So in the past, what we can see here is my colleague doing a connection in Port of Auckland in California. We installed outlets in the terminal. But if the vessel doesn't line up, you whether have to move the vessel or you have a lot of people coming out, and again, 21st century modern container terminal. How does it work with your operation? I don't think that many people coming out to do the connection is something you're looking for. If you think about the coverage, what you can achieve with placing every 50 meters an outlet, what doesn't not only cost a lot of money, but also in terms of operation, you create sort of red zones where you cannot connect. So in the end, you have to move the vessel or you cannot connect. And even getting close to it, these cables are super heavy. They weigh 10 kilos per meter. These are 2 cables. It's not easy to move them. You can do this coming from the vessel about 3 to 4 meters. That's fine. You get this done. But afterwards, I mean, you definitely need help. You need to call your colleagues. When we're looking at the situation that what some of the ports did in California, they acquired sort of an extension system. We built one as well. But most of the time, the terminals look like this. You simply don't have space. There's no space. George just mentioned this as well. It's really, really challenging. You have space about 2 meters, 1 meter 50. You cannot drive there something. There are bollards. It's impossible. What we learned from California, the regulation got stricter and stricter. So 2020, they had to connect 80% of the vessels. So they started putting an outlet at each end of the wharf or of the berth. And then they realized, okay, I have another vessel coming, and then the location is different. Then they added 2. Then they added 2 more. So in the end, they had 6 outlets. That's the main standard when you're looking into California. 6 outlets cost a lot of money, doing all the trenches, doing all the cabling, installing the outlets in the ground. But now, CARB, Californian Air and Resource Board, requires 100% of connections. I mean, LA and Long Beach invested approximately $150 million, and it seems like they have to invest same amount of money to reach this goal, 100% of connection. Why is 100% connection important? Because otherwise they face penalties because they are not compliant to the regulations. But if you're thinking ahead and at different ports, because the key drivers for shore power can be different, but in the end, you want to utilize your infrastructure. So all the equipment you're installing, especially the electrical equipment, frequency converter, transformers, trenching, cabling, I mean, you want to get most out of your money, and you want to utilize this because in the end, it's all about selling electricity and connecting as much vessels as you can and achieving 100% connection rate. And also 100% connection means 0 emission. So no one has a crystal ball, and we need to plan for the future. And so you need some kind of flexibility. And when Port of Auckland came to us and said, okay, we need a system that provides us the ultimate connection flexibility, we cannot add more volts. 1 volt is including cabling and installation and all is approximately $1 million. Maybe it's a little bit cheaper, but it's a lot of money for 1 volt. But also, they said that you can't make a Swiss cheese out of my terminal. There are cranes traveling over the deck, and there's a lot of steel in the ground, and it's not easy to dig any trenches and holes into the terminal. And they wanted to have a one-time investment for 20 years of lifetime, so one and done. Oops. So we started to analyze, and as Josh mentioned as well, we went there, did our studies, did the plugging, understood operation, learning how this could be done. And the only place where what we found and what was acceptable was we need to put it out, a track element outside the trench, and have a mobile shore power outlet that travels along to bring shore power to the vessel and not move the vessel to shore power. The next step was, after designing and proving all this concept, was building a system. And we actually, that's in our factory in Germany, where we created a test stand and installed a installed a fully functional system with a 20 meter of travel, because everything is super heavy, everything is big. So it's a real challenge. It sometimes looks nice on paper, but you need to do the real thing to learn what it means to do this connection and to prove that every single step is working, because bringing this out there, then it has to work. And so the good thing is that we have an international standard and that we can follow a lot of guidelines in terms of also of safety and connection procedures and making the system safe, that we can address here in the systems. And the good thing is it's working. I mean, shore power is used since many, many years and has its procedure, and it's working safely, and it's used for many years. So it's not a brand new technology, but the question is how we can improve this technology, how we can be innovative to create, to supply a smart infrastructure for the needs of the future, to get most out of your money and achieve 100% of connections. As you can see here, we have also established this as a Kirky mechanism to avoid that the system can be powered on without being correctly connected, or that you can disconnect without that the power is shut down. So these procedures are all well established, and in all our systems, or in all shore power systems, you will find such methods. We are very happy to install our first systems in Port of Hamburg. It's very exciting for us. It's a great honor to do so, and yeah, we're looking forward to the future, to see it on a terminal running. One important issue is installing something outside the terminal. I mean, we make it flexible, but you also need to make it safe. So it's a very big challenge to really find a good solution for each port, because there is no port like another, just like George mentioned before. So analyzing the terminal and getting the experts on board in each field, from cabling, cable management system, but also from protecting the system. We collaborate here with Shibata Fender team, one of the two leading fender manufacturers worldwide. And there are many different solutions how you can protect the system. What needs to be assured that at 100% compression of the fenders, that's what they designed for, the system is protected and not damaged. And we can achieve that. We have studied a lot of different ports together with Shibata to achieve this goal, to make a reliable one-time investment solution for the future of the ports. To sum up, yes, we designed to this criteria. Again, IEC 8005, that's sort of the standard Bible. You find in the different annexes the requirements for different vessel types. We designed this according to the EU Machinery Directive, corrosion protection C5M, that's according offshore classifications, the highest corrosion protection, IP66, 67 for electrical components, Kirky integration, as well as push-pull force detection to measure the safety of the system, and a clear signaling status. This can be adapted to each country requirements in terms of certification, and we also do a certification of the overall system with DNV in the next months. Igus is a family-owned company located nearby Cologne. Frank, our owner and CEO, is working right among us. We are more than 4,000 people worldwide. Biggest companies next to Germany is our headquarters for the Asian region in China, as well in Singapore, and yes, certainly the States and Rhode Island. And yeah, we have done many shore power systems already for different vessels and you need to do a good study to find the right system, and we are very excited about the development and the goal going green and zero emission of the ports, and hope that we can contribute a little bit to this goal. Thank you very much.
Sorry, Martin, I was offline, so I'm sorry. Thank you very much for your presentation. Very interesting, and it raises a lot of questions from my end, at least. I think the concept is very clear, and I think if you were to apply this to other types of terminals other than container terminals, let's say to general cargo berths, which have very limited fenders, you need to then come up with a solution which also addresses the fender challenge. Is that correct?
Yeah, absolutely. We always have to look at the power consumption of the vessel.
Right.
So less power consumption. Cargo vessels don't have a power consumption as a container vessel. They have much less. That means less cables or even less cross section. That means the smaller systems. And then we have to look also at the requirements. I mean, the vessels are not that big. The fenders don't compress that much. Sometimes you just have just bumpers, sort of. So there are possibilities, and we have studied this as well to achieve this, and it is possible. But for such investments, you need to do a good study, and it's really worth it. Can be preliminary study can be done easily with terminal plans if you receive overview plans and cross-section views. Then that works very well for first shot.
But is it true to say that if you combine it with the study on the fendering system and the whole berth quayside structure, then you can always solve it based on this particular concept?
We can do a lot of things, but always I wouldn't say that. But because there's some there are some challenges you will find probably, but I think in most of the times we can find a solution.
Right.
I mean, brownfield terminus is a critical part because they are not designed for shore power. There is no perfect solution for a brownfield terminal. You have always to do something, and the question is what you're doing.
Right. Now, since you must have, because you were hired by California to solve this riddle, right? And you right away concluded that the volts, having intermittent volts, ultimately is not going to be a good solution because it's going to be too costly. You might still end up with ships that you cannot serve, so you cannot reach the 100% target that you have in mind, right? So I assume, therefore, that you've looked at different concepts. Have you also looked at the whole concept of using barges? If you go to Singapore, every ship in the port is taking in fuel oil, so barges are along the water side. It's a huge volume of barges moving around there just for bringing fuel to the ships. It should not be too hard to run a cable to the center of the basin from which you can tap the power and connect it with the ship from the seaside, because then you would have ultimate flexibility in terms of where you pick your connection points.
I mean, you need a lot of experienced engineering to have, I mean, if I understand it right, you want to have a sort of outlet in the center of the basin, and then you connect the barge to this outlet, and then from the barge you to the barge you connect
the ship. You go to
the ship.
Yeah.
I think there are too many unknowns to the equations to solve this issue, and also in terms of operation, because I mean, a port is busy and they don't do what you always ask them to do, and sail wherever they want. So I think, I mean, we're dealing with medium voltage. It needs to be safe, and so it's an interesting approach. I could imagine that you can do this for smaller vessels if you have barges with big battery storage capacities, for example.
Right.
Could be an idea.
Yeah.
See what the future brings.
Right. Yeah. No, I can see the risk involved in that, because a ship might drop anchor, or it might hit the bottom of the terminal. The dredging of the terminal, regular dredging, would be a problem, etc., etc. Yep. Okay, let it be for the moment. I've been watching the general Q&A, but no questions have arisen from the audience. Before we go to the general discussion, Martin, one last question for you is, you've mentioned already a lot of lessons learned, I think, one of which is don't think in terms of all these vault solutions, because ultimately it's going to be too costly. You need to think outside that box. Are there any other lessons? Are there any other general lessons that you've learned from your experience in California and similar projects, of things that you should not do?
I mean, I don't want to say that vaults will never work for a terminal. That the lessons that we learned is that you need to get a lot of stakeholders on board, and that you need to not only look from an electrical point, and that you cannot compare one solution isolated, because you have the electrical equipment, but you have a lot of construction work. So if you design your overall layout plan of a shore power system, you need to have the e-house somewhere, and then you need to get the cables to the key wall, and then you need a cable management system. So there are three major components: electrical equipment, the construction work with the cabling, and the cable management system. And changing this setup, especially if you change from a vault to a flexible solution, that affects not only the construction and the cabling, but also the e-house. And for example, space available is never available on a container terminal. So if you have less vaults, you have less switch gear, you have a less footprint of the e-house. So there's different things that come together, and you need really to plan this accordingly with all stakeholders, and always keep in mind that changing something will change also your business case or your investment proposal, and that can make a real big difference.
Yeah, right. Yeah, right. Any other lessons with regards to dealing with the ships? Because our clients in this case are always the ports. The ports want something, and they want that because they are under political pressure to do something, and the shippers get they're free to have. They are just following the lead. Nothing. They don't need to do much, but talking to them and asking them what they could contribute to make life easier might make some sense. And I'm wondering if that ever happens, actually.
Yeah, it would have been great if we determined the cable management system on board the vessel where it's actually located. But this is gone. It happened, and there are so many vessels equipped already, especially for containers, that I think we cannot change anything on the ship side. What we learned from the ports, that the ports and the terminal operators, that the ports think about, okay, how do we have zones? Because it's always one transformer supplying one vessel. So you need to have some kind of zones, and where you supply shore power for one vessel. And as you have smaller vessels and bigger vessels, it's an approach that you say, okay, I have a 250-meter zone, and where I can supply one small vessel, and the next zone of 250 meters can supply another small vessel. But if I combine these two zones, so I switch together the transformers, I can supply full power to one big ship, because the big ship needs more power, so 7.5 MVA, for example, and the one zone can supply only 3.75 MVA. So that's a concept that I think it makes a lot of sense in terms of gaining flexibility, connecting all the vessels.
Yeah, right. Thank you very much, Martin, for your presentation. May I now then open the floor to all the panel members, basically on the same questions that I just asked for Martin. If you think outside the box, looking at Martin's presentation and the problems that he has highlighted, particularly with the volt systems, are there any other conceptual suggestions that you all might have in terms of approaching this maybe smarter in the future? George, Andrea, Jana, any suggestions that you might want to add, conceptually speaking, on how to approach this?
May I take the floor?
Yeah, sure.
What I see as a solution running already in Port of Kiel is that they have a dual use. They are using one transformer, one e-house for two different kind of vessels, for a cruise vessel as well as for a Ropax ferry. So what they are precisely doing, and the ambition is to do what you are just asking for. How can we use one infrastructure, one investment, and use it for different types of vessels, for different types of ships? And this is really challenging. It is individual to be handed over for the cable management, but it is really complex for the system integrators, for the Siemens and ABBs and PowerCons of this world. That's the big challenge on this one. For, I guess, Martin and me, we just care on each vessel individually because we need to hand over a special number or amount of cables according to the standard. We cannot say, oh, today I'm just handing over 2 of the 3 cables because I don't like more. But that will come up very, very soon. We are in the beginning. Even if shore power is now roughly 20 years old, we see that we are still a beginning branch, let's say. And there is, of course, a couple of hundreds, maybe 1,000 applications running worldwide, but there is many ships in many harbors. So we need many thousands of applications to be handed over very soon if we want to follow up the demand.
Right. Now, another question related to that, if you were to think about a port, if you were to build a brand new port, you would probably, from the viewpoint of electrification, approach things very differently, because the way we are talking today is shore power is a new challenge. And the port has, of course, an existing electrification system for powering the cranes and the lights and all kinds of other things. But the shore power approach, we start from the substation and we run cables from the substation or whatever production point to the ship. So it becomes a parallel system. If you were to start from scratch, would you not move towards a single system? Or is that something that would never really work because of the volume of power requirements is simply too different?
And I can tell you for the port of Hamburg, they have 300 different berths. So if you install a new port, a big port, that is, you cannot just believe that you can handle everything in one step. It's just too complex. So usually they are coming up with a new berth, let's say, where 2 or 3 or maybe 4 ships are next to each other. But a complete new port, well, that's really challenging.
No, I'm just fantasizing a brand new port in another location where, let's assume we are charged to build a brand new port, like in Singapore, like to us, it's a brand new port, 50 million TEUs or 60 million TEUs is the target. So that's massive. And I'm just wondering how they are approaching the electrical systems design development process in that context. Would you not approach it as a single system in that case? That is my question.
Yes, of course, that's the aim. You have one solution which fits to all the vessels, if possible, at least to all the container vessels.
Right. Right. Exactly.
I think the challenge for the port is, if you're building a new port, then to having a smart, flexible infrastructure is something that addresses the future. We have seen this also, for example, in Port of Hamburg. What Stemmann did for the cruise vessels is a trench with lifting plates, having it integrated in the terminal, or our flexible system which could be in the trench or outside the quay wall. But having flexible systems, I think it's something very important for the terminals to address future needs. I think that's what should be considered when you're building, especially a new terminal.
Yeah, right. And the flexibility comes from the trench. So the trench, you design the trench in such a way that you can add more cables later if that is needed. Huh?
Yeah, actually, or you have the system running in the trench back and forward. So you have the trolley, what we saw outside, can be also integrated in the trench.
Right.
So that could be a design for a new terminal.
Yeah, makes sense. That makes sense. Or a redesign for an existing one.
Depends on the terminal. With container and the steel inside there, no.
No, I know. That's going to be very complicated. Okay, we are running out of time. Is there any other topics, any of our other esteemed panel members, Jana in particular and Andrea, who have not had so much floor space yet? Is there anything that you would want to say in closing, Andrea and Jana?
I mean, it's a challenging future, as you said. We will probably draw our focus much more to that topic as it is today.
Yeah, exactly.
From the cables point of view, as a cable manufacturer, we do have the solution to that day. I don't know the technology of tomorrow.
Yeah.
So we are partnering very closely with the system providers, with the equipment manufacturers. It's definitely a challenging and very demanding future, because there's a lot of question marks on many other questions, such as how to generate the tremendous amount of energy that will be needed just to feed the port.
Yeah.
I mean, the port too, as you mentioned Singapore earlier, if you just recall the size of that terminal once it is finished, and when you then see how many vessels at the same time may lay there, and what will be the solution for the vessels that are not in the port but in front of the port. I mean, zero emission in port operation it's like it's very limited. Outside the port, it's just a few meters away, you create emission. So what are we going to do with the waiting time whilst the vessels are waiting in front of the port? What will be the solution there? There's a lot of things to come, and it's very interesting to be part of that game and develop the product according to the demands.
Yeah, you're right. Is just a curveball really? Is copper going to be a problem? Copper, because I understand copper supply is going to be a problem over the next few years because of this revolution.
That's very difficult to say. I mean, I don't have the glass ball. At the moment, it is extremely high, motivating others to invest in grabbing copper. But when it comes to other materials, if this is the background of your question, it doesn't bring the efficiency, the safety aspects, and also not the savings actually in the pocket that you would expect, because all tests that we have done so far are ending up in a lot of extra compromises, which at the end of the day are not meaning efficiency.
Yeah, right. So there is no real alternative in sight as of yet.
Not at the moment, at least.
Right.
The question is only if maybe from the in order to reduce the amount of copper in these cables, if the voltage class will then increase, but then you need to think about bigger transformers and then bigger. Everything must be bigger to handle a higher voltage class. So that's a trade-off that this case the system integrators needs to face for sure.
Yeah. Right. Okay, we'll have to leave it at that. There are many more aspects that we would love to speak about, but time is of the essence. So I would like to thank everybody for its contribution. It was far more interesting than I expected. So thanks again very much. Thank you, IJ, for inviting me for this event, and thank you, Transport Events, for making this possible. And we'll hope to meet again in person or during one of our future Transport Events conferences, if that is possible. Thanks, Ajay. Over to you.
A special thank you to our moderator, Mr. Anthony Vers-Lewis from Roland Berger, for moderating today's webinar. Once again, we would like to thank Brisbane Group for their valued sponsorship. We thank Ms. Jana Blechschmidt from Brisbane Group for her valued support in making this webinar possible. I would also like to take this opportunity to thank our valued panelists for their time in preparing and presenting their insightful presentations. The presentations given today and an on-demand recording of this webinar will be available to all registered attendees tomorrow free of charge at www.transportevents.com. Please may I ask everyone to follow Transport Events on LinkedIn, Instagram, Facebook, and YouTube, and visit our website, www.transportevents.com for latest information on our market-leading online weekly webinars and annual in-person trade events. Please email me if you would like to have your company's latest full-color logo and company details branded on the next available webinar at ajay@transportevents.com, spelled AJAY@transportevents.com. And finally, please register for next week's Transport Events Market Leading webinar, generously sponsored by Yieldport, taking place on Thursday, 28th October at the same time, 10 a.m. to 11:30 a.m. CEST. Thank you very much, and we look forward to meet you again on Thursday, 28th October. Thank you, everyone. Thank you for joining us. Thank you.
Thank you.
Have a great day.
Thank you.
Bye-bye.
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 Bye.